The amount of water that's available for consumption varies around the globe, and the population density of people that's consuming that water also varies. We see variable consumption of water as we travel around our globe. If we look into the past and the future, we see that there will be differences in the amount of available water that we are using, and on this chart we see the water withdrawal as a percentage of total available water. So areas on the globe that are brown and tan are consuming more than 40, well, the brown water areas are consuming more than 40% of the available water in that region. The tan waters are consuming between 20 and 40%. And then the blue waters are good. They're not consuming a large percentage of the water that is available for consumption. So if we look at the map from 1995, you can see that there's much more blue than there is tan and brown. And the areas where we see some issues with the amount of available water compared to the amount that's being withdrawn and used, we really only see the tan and brown in Northern Africa, in the Middle East, India, and then parts of Asia. If we look into the near future, into 2025, we see more brown and more tan on the map than we did in 1995. So all of a sudden the US is tan, whereas it used to be blue. Europe, much of Europe, or more of Europe, is tan, so they're experiencing more water stress. And then China is also experiencing more stress. And so we're seeing more and more water being withdrawn compared to the amount of water available. Before we talk too much about consumption of water, I wanted to talk about the different types of withdrawals of water that you can have from natural systems. So there's two types really. There's consumptive withdrawals and non-consumptive withdrawals. Non-consumptive withdrawals means that the water is taken out of a natural reservoir, it's used, it can be cleaned, and then returned back to the natural reservoir. With consumptive use, the water is used and then it's lost to evaporation, or it is lost to groundwater, and so it's not available to be used again. So many industrial uses, such as washing and flushing of wastes, washing industrial equipment, using water in electricity plants where you're using it as like cooling water. A lot of that water can then be returned to the source. But agriculture, for example, that's the largest consumptive use of water. So when you irrigate a crop, the water goes onto the crop, the plants withdraw the water, they either keep the water in the plant or that water is lost to transpiration. So agriculture, that's a huge use of water around the world. And if you look at this map, it talks about the proportion of water that's withdrawn for agriculture out of all water withdrawn. So this is, they added up the amount of water that's withdrawn in a country total, and then they look at what percentage of that was withdrawn to use for agriculture. The countries that have red and orange, that means most of the water they withdraw from natural systems is used for agriculture, and then areas that are blue and kind of a light blue color, in those countries most of the water is not used for agriculture but for other things. And so we see that Northern Africa, again the Middle East, parts of Asia, Australia, the Central America and Mexico, and some parts of South America, they're using a lot of their water for agriculture, whereas Europe, the Soviet Union, and, well, Russia, sorry that dates me, and the United States, we're not withdrawing as much for agriculture. If you look at an average worldwide, about 70% of all water, fresh water that's withdrawn from natural systems is used for agriculture. But this varies a lot depending on the region. So we just saw that this is just showing the same information we saw on a map on the previous slide, now in a graph form. So here we're seeing that, in Europe, only 21% of water that's withdrawn is used for agriculture, but Asia and Africa, 82% is used for agriculture. So that does vary a lot depending on what part of the world you are in. This this chart, I keep going back and forth from maps to charts. On this chart, we're looking at the global population. So this y-axis on the right is showing population in millions of people. And you can see that that number is going up and up and up. So this black line is showing the population and how it's increasing over time. On the left y-axis, we have the water withdrawal per year, and that's these bars on the chart. And so again, you can see that this number, the bars are getting larger each year, and we're withdrawing more water each year for use. If you look at each bar, it demonstrates the different uses of the water that's withdrawn. So the blue bar is agriculture, the red part of the bar is industry, the green bar is municipal use, and then that purple bar is evaporation from artificial lakes. So these are lakes that exist behind dams. The water stays there for a long amount of time, and so a lot of it evaporates from the surface of the lake. And so that number is increasing as we dam up more rivers. But you can see as we need to grow more food, the blue bar for agriculture is increasing. The red bar is not increasing as much. So red is mostly used for generation of electricity. That's when they say industry, they're talking about electricity generation. The municipal withdrawal is increasing over time as we have more and more people that are consuming water. And that's for household use. Usage it's not uniform around the globe. Part of that is a factor of convenience. So some parts of the countries it's more difficult to consume water because it's more difficult to access it. So in Africa, we see that the average household uses about 47 liters of water per person. In Asia, that number is 95 liters, so twice as much. In the United Kingdom, the average is 334 liters, so about 80 times as much as Africa. And then in the United States, the average person consumes 578 liters per day. And so that number is more than 10 times the amount of water that's consumed by a citizen in Africa. And so water use is not consistent across the globe, and it's good to remember, like people in the United States, we are using more than 10 times the amount of domestic water than people in developing countries in Africa. Part of the reason for that we just mentioned is because access to clean water is not universal, and just access to water in general is not universal. In many developing countries, it's not just the scarcity then of water that's an issue, but the quality of water that's an issue. If we look at parts of Africa and Asia, less than 65% of the population has access to clean water that is safe for them to drink. Much of the contamination of water in these countries is due to a lack of sanitation systems. And so that means that human waste is not contained, and it can contaminate surface water and water wells, which would contaminate groundwater. And that happens when water is washed off of land surfaces as runoff, and it can get into wells and contaminate them. So on this map, it shows the percentage of people who do not have access to sanitation. And so there's a lot of red on this graph, which means that more than 50% of people in that country do not have access to sanitation. So much of Africa and much of Asia don't have access to that. Some of the more developed countries in Europe, North America, and then Australia, about 95% or even more of those people do have access to sanitation. Okay, so we talked about industrial usage. Industrial usage is primarily for energy production, so that can be used in either hydroelectric plants, so dams that are being used to create energy. It can also be used in just other types of electricity producing, generating facilities that also use water. Dams are critically important around the globe in terms of energy production. Dams provide about 17% of worldwide electricity, and it varies a lot by country. So you can see on this chart showing the amount of electricity produced from dams or hydroelectric power. China produces the most by far, followed by Brazil, Canada, and the United States. Dams are also, there's other benefits to dams. They prevent flooding in some regions, and they provide a reliable source of water, which is important for the desert southwestern United States. There are some advantages to dams, and we will talk about impacts of dams in a future lecture. Some advantages include that it's a renewable and a sustainable energy source. It provides stable energy prices because once a dam is built, the cost to run it is fairly low. They provide water storage at the same time, and when you're operating the hydroelectric facility, it does not emit greenhouse gases. Of course, when you're building the dam, that requires a lot of input, like to make the concrete and transportation and to put all of the facilities in place. That does generate greenhouse gases. Okay, so this concludes our global water consumption.